Welcome to 0 Degree Science. Have you ever wondered how your car turns smoothly without skidding? The secret lies in a smart mechanical system called the differential. In this video, we'll explore how it works and why it's essential for every vehicle. Let's get started. The person who invented the differential was truly great. Without a differential, cars would be unable to make safe turns. When a car turns, the inside wheel follows a shorter path than the outside wheel. This means the outside wheel must travel a longer distance in the same amount of time, requiring it to rotate faster. If both wheels on a curve rotate at the same speed, it will cause tire slippage and wear. Cars would become difficult to control, just an accident such as broken axles could occur. The invention of the differential perfectly solved this problem by allowing the wheels to spin at different speeds. So, how is this achieved? To help you understand better, let's start with the most basic model. Imagine these are the wheels on both sides of the car. We can mount the inner end of each axle on separate shafts and attach a spoke to each. By turning the spokes, we can rotate the two wheels separately. If we use a horizontal bar, we can rotate both wheels at the same time, at the same speed, and in the same direction. Now, we need a device to fix this crossbar in place. However, this support is not locked to the shaft. It can rotate freely. By turning this support, we can achieve differential motion. Let's turn two wheels, but this does not make one wheel faster than the other to achieve a turn. Instead, we can fix the connection of this rod and change it to a rotation axis, allowing the crossbar to swing freely. In this way, the crossbar can spin both wheels at the same speed. Even if one of the wheels stops, the other wheel can still turn. However, in this situation, the crossbar will swing until no spokes can be driven to turn either wheel. To solve this, we need to add another crossbar and more spokes to ensure continuous motion. When one wheel stops turning, the crossbar will continue to push the spokes of the other wheel. This prevents the crossbar from swinging freely. To reduce the jerky motion caused by gaps between the spokes, we can add more spokes to create a smoother and more continuous movement. In fact, this is the prototype of the gear. Now, let's look at the actual differential. All internal components are enclosed within the main housing. The outer shell prevents debris from entering and damaging the interior. Additionally, gears are sealed with lubricating oil, which helps reduce wear and friction. The engine provides power through the pinion gear, ensuring smooth operation. Compared to straight-cut gears, spiral-cut gears increase the meshing area between the gears and the pinion. In a planetary gear system, the planetary gears are connected to the center of the system and rotate around the same axis as the ring gear. Generally, planetary gears have two opposite gears, but they can also rotate on their own axis. For better visualization, we will show only one planetary gear here. The planetary gear is connected to two other gears called side gears. The half-axle gears connect to the two wheels, similar to the spokes of a wheel. The engine drives the pinion through the transmission shaft, which in turn drives the ring gear. As the ring gear rotates, the planetary gear connected to it also rotates. If the car moves in a straight line, the forces on both rear wheels are equal. As a result, the planetary gears move along with the ring gear without rotating on their own axis. The torque is transmitted to the side gears, causing them to rotate at the same speed and in the same direction as the ring gear. However, when the car turns left, the right wheel spins faster, causing the planetary gear to rotate and slow down the left gear. The speed difference between the two side gears is inversely proportional. This is how an open differential works. Despite its advantages, an open differential has a drawback. It sends most of the power, RPM, to the wheel with the least friction, which can cause the wheel to slip. This becomes dangerous when driving on surfaces like ice. To solve this problem, a slightly different design is used: the limited slip differential. What happens next? Let's break it down in the next discussion. So, that's how a differential helps your car turn smoothly by allowing the wheels to rotate at different speeds. If you found this explanation helpful, don't forget to like, share, and subscribe to 0 Degree Science for more amazing science and engineering videos. Thanks for watching, and see you in the next one.